Famously, electricity and water don't get on very well.
Stand by, going to charge the unit. Power on.
We've asked special effects wizard Mark Turner to prove it.
3, 2, 1.
That's what nearly 10,000 volts meeting a tank full of water looks like. Do not copy this in any way. Now, of course, that was a big effect that we set up.
But what it does demonstrate is the power of electricity and the fact that even though it can create a lot of good things, what really needs to be very respectful of it.
Next, we're going to try and recreate the sort of explosion you might get when a tiny bit of water seeps through the insulation of a damaged cable.
So what we've done here is we first prepared the cable. We've done this by cutting the insulation and letting see the inside current carrying core and the outside, which is the ground.
So that cable is now damaged in the same way that a cable would be damaged if a digger had gone through it or if the ground had shifted.
Exactly.
The core and the earthing mesh aren't touching, but add water, which in reality could take time to penetrate, and there's a connection.
Standing by to fire. 3, 2, 1.
Wow, that was quite big, wasn't it?
I think so. Let's go and see what it looks like.
What are you expecting to see here?
I expect to see some blacked cable, ideally. And look, you can see here some of it's blackened out.
The current passes from the inner core through the water to the outer earthing wires, causing a spark and a burst of flame. And this is the story behind most pavement explosions.
Of course, if the cable would have caught fire or anything surrounding it would have caught fire, then we're no longer talking about the electrical spark. You're now talking about a standard fire.
By this point, circuit breakers would cut the supply. What's left to fizzle and burn is the insulation. And sometimes, in manholes, flammable gases build up, which, when ignited, can really go bang.
Oh my God.